Welcome back, physics fans, and we're going to do number 18 here, which is a system a little bit more complex than the basic ones of Physics 11. So let's just start drawing our free body diagrams. We have two masses up on top of a cement brick of some sort. It has a coefficient of friction of 0.25. The two masses are 9 kilograms and 1 kilogram, and there's a 10 kilogram mass hanging off the edge of a frictionless, massless pulley. Okay, free body diagrams. We're going to do M1 here, and the mass of M1 is 9 kilograms. And this is M2, and the mass of this is 1 kilogram. And this is M3, and the mass of this is 10 kilograms. Let's just draw them. There's a normal and a force of gravity because it's on a surface. This one has a normal and a force of gravity because it's on a surface. But this one doesn't have a normal. It has a tension force up and a force of gravity down. Now, this tension is just wrapped around that pulley, so those tensions are equal, and we're going to call them T, and the tension force between these is T2. Okay, so T is pulling M2. Okay, T is pulling M2. There's T. And T2 is pulling M1. But T2 is then pulling back on M2. It's going to be pulling back and forth, so this is going to be T2. Now, let's add the frictions. There's no friction on M3, so there's only a friction force here and a friction force here. Let's calculate what those friction forces are. The friction force on number one is mu mg because it's a flat surface. We can use mu mg. That's only for flat surfaces. And that is going to be 0.25 times the mass, which is 9, times 9.8. Okay, and that'll give us our friction. Let me just move this over. I have room over to the left here. I don't know why I'm clogging up here. There's going to be a lot of stuff over. And that didn't work. Let's select all of this and move it over. There we go. To make myself have some room. And that makes the force of friction. Let's pull up Mr. Calculator. No, Mr. Calculator, there we go. It is 0.25 times 9 times 9.8. And that is going to be 22.05 newtons. Okay, so that's an external force acting on the system, and mainly through that block. Let's do the force of friction on this guy. Force of friction on this guy is mu mg, and that is going to be 0.25. It's obviously made out of the same material, has the same coefficient of friction. And M2 is 1 kilogram, and this is 9.8. So this is going to be 2.45 newtons. Let's just verify that. 0.25 times 1 times 9.8. Okay. And so that's an external force acting on it. Okay, and that's going to be the force of friction of number 2. That's the force of friction of number 1. And this M3 person here, that is just up and down. There's only going to be a force of gravity on it. So that's the force of gravity of number 3. We just have to figure out what that is, and that's just mg, which is 9.8. Whoops, m is 10. 10 kilograms times gravitational field strength of 9.8 newtons per kilogram. So force of gravity is going to be 98 newtons. So we've calculated all our numbers, but that's all on individual basis here. We haven't done anything for acceleration yet, and we haven't done anything for tension. Okay, let's look at our system. The system as a whole has a mass of 20 kilograms. 1 plus 9 plus 10. Let's look at the sum of the forces acting on the system. F net equals MA. Now remember, the internal forces, the tension pulling one way on one block and then the opposite way on the other block, they cancel out. So it's just going to be the force of gravity of number 3 minus the force of friction of number 2 minus the force of friction of number 1. And that's going to work on the mass of the system times the acceleration. Okay, so we used Newton's second law and applied it to the whole system. And these forces that I've been talking about and calculating are what's acting on the system. These are the external forces acting on each of these blocks. So this is going to be 98 minus the force of friction of number 2, which is 2.45, minus the friction force on that one, which is 2205. And it's moving a system's mass of 20 kilograms, and then we're trying to find A. So it's going to be 98 minus that number minus that number, and we'll get 73.7, 73.5. So this is going to be 73.5 is equal to 20A. So the acceleration is going to equal, divide this by 20, 3.675 meters per second. You should probably, if this was an honors class and stuff like that, you should probably tell me the direction. It's either right for M1 and M2 or down for M3. But it's pretty intuitive here. Now, let's start working on these tensions. Okay, the middle one is going to be the hardest. You can see there's 3 forces in there. These are 2 forces and 2 forces. So let's just do the easier ones first. So the sum of the forces is equal to F net equals MA. So what's winning is T2. What's losing is the force of friction, and that equals MA. Now it's the force of friction of number 1, and it's the mass of number 1, not the mass of the system. So T2 minus 22.05 is going to equal 9 times 3.675. We just calculated that over there in blue. So it's on the calculator still. Let's multiply that by 9 and add 22.05. And that'll be the tension. Tension 2 is going to equal 55.125 newtons. Okay. Now, we could do either one of them, and then the other one will be the check. Because we use, here we could solve for tension, and here we can solve for tension. So the only two, that's the only unknown we don't have. So I'll do the middle one. Okay, why not? And I'll do this one in blue over here. I've done it in blue. Let's do it in black. Here we go. The sum of the forces is equal to F net equals MA. So that's going to be T minus T2 minus the force of friction of number 2 is equal to the mass of number 2 times the acceleration. So T minus 55.125 minus 2.45 is equal to the mass 1 times 3.675. Okay, I need a little bit more room here, so yeah, moving over, clear it up. So let's just do that. It's going to be 1 times this plus that number plus that number. When they come over to the other side, they become positive. So it's going to be that number plus that number plus 2.45. And we get T is equal to 61.25 newtons. So we have solved it. We have the acceleration, we have the tension, and we have tension 2. So we'll just use the last one as the check. Okay, we'll just use the last one as the check because we have all of it. But we'll do it. Okay, this also it's good practice. This is an up and down, and it's accelerating downwards. So we write out Newton's second law. Sum of the forces is equal to F net equals ma. And the downward force is winning, force of gravity. And that's the force of gravity on number 3, not all of them, not the whole system, just on number 3, because we're only looking at M3 right now. Minus that tension force we just calculated is the mass of number 3 times the acceleration. So this is 98 minus 61.25. Does that equal the mass of number 3, 10, times 3.675? So 98 minus that is 36.75 newtons. And does that equal 10 times that, which is 36.75? You bet it does. Double check mark, smiley face. Oh yeah, that's a lot of work, so celebration. Okay, remember, smash that like button, subscribe often, ring the bell so that you get annoyed by whenever I post. And let's hear the jingle come on up. Let's get that outro happening. Dun, dun,